Hi guys, Daniele here. Today I want to talk about displaying the content of a database inside a Cartesian plane. In order to display the content of that database, the data library has two objects, one named data.cartesian and one named data.distances. We won't enter into the details of the second one because it's a bit more advanced, but you have to know that most of the features of data.cartesians also apply to data.distances. So maybe we'll enter into details in a future video with data.distances, but if you want to get started on that, most of the things we are seeing today also apply to the other objects. In order to display a database, we need to have a database in the first place. What I'm doing is I'm creating a data.base object named mydb, and I'm filling it up with a database we had saved in a previous video named mydb.txt. So I'll do that. I'll put a link in the description for you to download the file if you want, or you can use your own file, of course. If you remember, this dataset had three tables: the sample table, the grain table, and the Alice table. We are going to use, I think, the first two tables to begin with. And in order to display the database with data.cartesian, let's create a data.cartesian object. When we do that, a white canvas pops up with the instruction to set the database and table attributes. Indeed, data.cartesian is nothing but a window on a database. It's not a database in itself, so we have to link it to some existing database. In our case, the database is called mydb, so we have to put mydb as database name. And we have to put the table we want to display as table name, for instance, samples. That's not enough. We need to also put two more things in order to make it work. Actually, three. The two things we have to put are called X field and Y field. And those are the names of the columns that will be displayed on the X-axis and on the Y-axis, respectively. So on the X-axis, we might want to display the spread, and on the Y-axis, we might want to display the central. I strongly suggest you to also change the content field attribute. The content field attribute is the name of one or more columns that will be output whenever you interact with the points in your plot. So whenever you hover them, you click on them, and so on. What kind of information do you want to be output about them? By default, it's a content column, but our table does not have any column named content. We may want to put file name instead, because we may want to spit out the file name of the points I'm interacting with. This is enough to get us started. You see that our entire table has been plotted here. Each one of these little dots correspond to one element in the table. We can see the ID and the properties in the legend. And we may want to play the corresponding samples whenever we hover on them. And in order to do that, we can put a bach.print object connected to the second outlet. And if we go to the Max console, we notice that whenever we hover a point, the information about its file name, actually the content field we asked, is sent out. And whenever we leave the point, a hover known message is given. Also, incidentally, whenever we click on a point, a click message is given. So we might want to intercept the click instead of the hovering in some occasions. So what we do now is intercept the file name of the hovered point and load it, open it in a sfplay and play it whenever I go with the mouse on a point. This is not too hard. We have to retrieve the hover message, whatever comes after hover, and then we have to retrieve the file name. And since we want to communicate with Max objects later, we need to put @m, so open $11, for instance, that's going to be sent to our sfplay. Very good. Whenever there's no match, so there's no file name in the incoming list, we may want to connect the bach.keys object sends out a bang from the right outlet. We may want to connect it to a 0 message so that sfplay will be turned off. Let's add an easy DAC and we should be good to go. Okay, so you see that when I'm hovering with the mouse, the corresponding sample is being played. That's the basic of the interaction in data.cartesian. Let's take another example already. Here we have the same data.cartesian object displaying a table named grains. So it's not samples, it's grains. The content field is not just the file name, but it's also the start and duration columns. Because if you remember, grains contained some short excerpt from a Beethoven symphony. On the X field, there's a centroid. On the Y field, there's the loudness. And we can do the same thing as we did before. This is exactly the same mechanism, except that we are accounting for a start and an ending point. So a start and a duration. So whenever we hover, we have the corresponding grain. There's no fading in, no fading out. This is very rough. That's just to give you an idea of how things can be easily done. The data.cartesian object also has an important attribute named where. The where attribute accepts a symbol to specify a condition for the elements to be displayed. This is exactly the same condition we give to the where clause when we do queries in SQLite. So we talked about this in a previous episode. So that's the same syntax, exactly the same syntax. When we do that, you just have to be careful that currently the attribute is a symbol, so you have to put some double quotes for the condition. You cannot do that, but you have to put the double quotes. It's gonna probably change in the future. You will be allowed to have more than one element, and so not just a symbol, and removing the double quotes will be okay. But for the time being, you have to put double quotes on the condition. And when you do that, for instance, when I set the where attribute as the start less than 60,000, I only get the portion of dataset that matches the condition. So where the starting point is less than 1 minute. To remove the condition, you can just send a where message. So every point is displayed again.
You may have noticed that our points are colored now. Indeed, there are other attributes that you can modify in order to tweak the size, the color, and the shape of each one of our dots. And those are called, indeed, size field, color field, and shape field. You can set them to a column, which will then handle the color, the shape, and the size of each one of the dots. To navigate, you can use the trackpad, as usual, or the mouse wheel. In order to zoom, on the x-axis, you can use Command and the mouse wheel up and down on Mac, and Control and the mouse wheel up and down on Windows. And to zoom on the Y direction, you can add the Alt key to this combination.
One other thing we may do with a Cartesian display is to retrieve the nearest neighbors with respect to a specific Cartesian point. What does it mean? Well, it means that if we take a Cartesian point with specific coordinates, in this case 3.9 and 0.75, so we are more or less here, okay? We are asking what's the nearest entry that matches those coordinates. And the answer is probably this element here. And the answer comes out from the third outlet. Let's see what's printed. And what's printed is KNN with the file name of the nearest element. We could have chosen the 3 nearest elements instead of just one. And what we have gotten here are the 3 elements that are nearest to that specific point in the Cartesian plane. Now we are playing just one of them, the first one. If we wanted to play a random one, we could have added a bach.random at max depth 1 here. And this will play one of the random 3 nearest neighbors. Here you go. Let's take another example, so always based on K and N. And in these examples, we have the same thing as before, except that we are forcing the domain to be between 0 and 7. The domain is the x-axis range, and the range to be between 0.5 and 1. The range is the y-axis range. And we are plotting the loudness on the x field and the spread on the y field. So let's do that. And this is handy because now we can take a LCD, which has been put a transparent background. So BG transparent is on. And what we can do is we can superpose it if you want. Whenever we drag the mouse, the corresponding coordinate is output and convert it into and renormalized to the coordinates of our plotted diagram. So between 0 and 7, the x, and between 0.5 and 1, the y. And the corresponding nearest neighbor is output and played back. You can imagine this patch to be expanded to account for graphic drawings on a canvas and so on. I want to give you one last example. And this last example shows another feature of the data Cartesian object. And this feature is called turtle. The turtle is a sort of hat we put on some special grain and then can be switched from one grain to another. So in order to set a turtle, there are several ways of doing that. If you give a coordinate, the turtle will be set on the nearest grain with respect to that coordinate. So in this case, we expect it to be set here. And indeed, if we do set turtle, you see that this element gets a little hat, hexagonal hat, which is called the turtle. And nothing happens because we use set turtle. If we use the turtle instead of set turtle, what happens is also that some information is sent out from the second outlet, namely the information about the content fields of the element. Indeed, let's go to the Max console, and you see that the content fields of the element are sent out with a turtle symbol. And the content fields were the file names and the sample ID. So we can play it back as we did it before, exactly, when we turtle. And then you have some turtle messages for moving the turtle from one element to another. If you're familiar or somehow familiar with the turtle graphics of the Logo programming language, this is kind of similar. That's why we call it turtle. And one of the messages, the most useful one probably, is turtle delta. What happens is that the turtle moves by a certain amount, 0.4 on the x-axis and 0 on the y-axis. And then the nearest neighbor is found and the turtle is put on the nearest neighbor. So for instance, if we go here, we expect the nearest neighbor to be this one. And indeed, the turtle goes there. And so on, and so on, and so on, and so on, and so on. So the nearest point with respect to the movement gets the turtle, and the turtle is output. And again, this works in combination also with the where clause, with the where attribute. So we can move the turtle between a certain group of entries, and the turtle will be put somewhere else, and so on. Okay, that's pretty much it for today. I hope you learned how to display a database in Cartesian form. I hope you liked this video, and we will continue to make videos on databases in the future with more advanced topics, so stay tuned. But for the time being, this video closes the first part of our series, and thank you very much for following it, and have fun.